So today I'm going to take you all to chapter number 2 that deals with measurement errors, traceability, and calibration. So you're going to learn about measurement errors. As we know, when we do any measurement, there are bound to be errors. Okay, there are bound to be errors, especially when you're using high precision instruments. And you need to understand what are the types of error that can occur, what are the sources of the error, how can we minimize the errors, okay, and whether if the measurement is done by someone else, how reliable are the data. Sometimes people do the measurement for you and you don't trust them. You don't trust, and then you go and repeat the measurement, you found that the readings are different. So there are bound to be some kind of errors in measurement. So this is a very important topic. It gives you an overall idea about what are systematic errors, what are random errors, what are the causes of systematic errors, and so on. So briefly, we just take a look at what you're going to learn in this topic. Okay, you will learn about the causes of measurement errors. And you can divide this into three main categories. You must remember all measurement errors, you can classify them into three main categories of measurement errors. And then you will look at types of measurement error. Okay, again, the type of measurement error you can subdivide into two basic types, systematic error or random error. Okay, if they are systematic error, what are the possible causes of these systematic errors? And how can we minimize them? Okay, you must take all effort to minimize errors in measurement. And then there are also random errors that can occur. What are the possible causes of random error? So you must be aware that there are two types of error, systematic error and random error, and they can occur in combination. In any measurement, you can have both systematic error and random errors. Okay. Now, because systematic errors can be reduced or eliminated, we call them controllable errors. So we will go into details about controllable error. Okay, this part here deals with controllable error. And then we will look at how you analyze random error, very simple method of analyzing random error. And then we will look at what is known as traceability. And traceability comes in conjunction with calibration. Whenever you have an instrument after some time of use, normally about 6 months, you need to calibrate the instrument and to find out whether you are getting correct reading or not. So when we do calibration, we compare with the highest standard. Okay, when you compare with the highest standard, the highest standard itself must have been calibrated using another higher standard. Okay, so your instrument after calibration, it must be traceable, traceable to a higher standard. Then higher standard is traceable even to a much higher standard, and so on. So at each level, we call this traceability chain, and it must be properly documented. So we will look into that in more detail. First of all, what are the learning outcome? Yeah, at the end of this topic, you should be able to identify causes of measurement error. Okay, in general, we're just looking at overall concept of measurement. If you do measurement, what are the main causes of measurement error? What are the types of measurement error that can possibly occur? Okay, and what are systematic and random errors? How do you differentiate between them? What is the difference between systematic and random errors? And then how do you eliminate or reduce? Okay, in fact, systematic errors, you can try your best to reduce them. And then even random errors. Random errors, probably you're doing the measurement on higher levels, for example, maybe second or third floor. There's a lot of vibration. When you turn on the aircon system, there's vibration in your room. So that may cause random fluctuation in the reading that you can reduce by doing the measurement at a lower floor or ground floor. And then you must be able to perform calculation involving measurement errors. For example, simplest error will be cosine error. You must be able to do calculation as well as error due to temperature rise. Now later I'm going to give you all activities I mentioned earlier that will help you to understand now what are the main causes of error, and okay, and how to solve these problems. Okay, we look at main causes of measurement error. Okay, whenever we do any measurement using an instrument, there are three main causes of error. Can you all just name one possible cause of measurement errors? Okay, just put that in the chat box so everyone can see. Okay, any idea, anyone? What is the possible cause of measurement error? If you look at this picture, it will give you some idea. Assuming this person is making this measurement, and then you get the data, you get the results from there. Anyone? What is parallax error? Maybe I think parallax error is something that all of you have come across very commonly here. Now, parallax error is due to what? Is it due to the instrument, or is it due to the operator? Operator, correct. Parallax error is due to operator. So operator themselves can introduce errors in the measurement. So if you look at all the errors that can occur, you can classify into three basic categories. Okay, one will be error in the instrument itself. Okay, probably the instrument is very old, or it has been dropped, not properly calibrated, not properly kept, for example. So those can cause errors in measurement due to the instrument. Instrument can be defective, for example. The other main source of error will be the measurement process itself. Now, what is meant by measurement process? As you all mentioned just now, the parallax error is a measurement process error. Okay, it is introduced by the operator. Okay, the way you take the measurement is there are some instrument. Okay, if there is a gap between the needle or the pointer and the scale, then there might be parallax error. This parallax error is introduced by the operator. So this is part of the measurement process. Sometimes the way the instrument is held, or the way the component is mounted, is not mounted properly. And during the measurement, you'll find that there may be alignment error and so on. So these errors are introduced during the measurement process. Now, what is the other main source of error besides errors in instrument measurement process? There's another factor. Not many people take that into account in measurement, in any measurement problem. What is the other main cause of factor? Anybody? Environment. Okay. So why environment is important? Because if you look at most of the instruments, as I mentioned the other day, most of the instruments are made in the colder countries like Japan, Germany, and so on, and they are all calibrated at a standard temperature of 20 degrees C. Okay, when you do the measurement at 20 degrees C, you get the correct reading. When you come to your own workshop, own lab, where the temperature may be 25 or 30, you are already introducing an error. Okay, so that error is due to the temperature rise. So that's the reason this person you can see wearing glove. A very simple precaution. Don't let your body heat transfer to the instrument. And so these are due to environmental factors. So the measurement error, you can subdivide them into three main categories. Error due to instrument. What are errors due to instrument? Example will be calibration error. Okay, the instrument that you're using contain calibration error, meaning that during the process of calibration, an error has been introduced into the instrument. Error can also be due to mechanical wear. Okay, this is very obvious. If you have moving parts in the instrument and you have been using it for a very long time, you can introduce mechanical wear in the instrument. So the wear itself can cause errors in the measurement. Aging, for example, an instrument that has been collecting dust and not used for a long time. Okay, yes, probably the instrument part of it has rusted. That also can cause error. Hysteresis, backlash, improper handling and care. Okay, these are quite straightforward. The instrument is not properly handled, and someone may have dropped it and just drop on the table. After some time, especially if you have electronic mechanism inside there, and then you'll find that this will cause error. But what are hysteresis? Okay, maybe you've come across this term earlier, but very quick revision. What are hysteresis error? Now, hysteresis error occurs. Why? Because it depends on the direction we do the measurement. I'll just show you one example here. Now, assuming that you want to measure the diameter of this object here, there are two ways of measuring. Okay, in this example, it is shown. The measurement is done along the increasing direction. You move the jaw out and then take the reading. Probably you get 14.41. Okay, when you move the jaw in, you take the reading, you get another reading. That is a very small error. Here you can see a difference, very small error. Okay, so this error actually depends on the direction. There is some background noise. Let me mute on. Let me mute on again. Okay, so if you look at this graph, it will become clearer. Now this is the input, this is the output. For a particular input value, input means that movement of this jaw becomes the input. Now for a particular input, the output value, the, the output reading will depend on whether we are taking the measurement in increasing or decreasing manner. This is hysteresis error. Now those who have your microphone on, please check your microphone unless you want to say something. Uh, please turn off. I'm trying to mute all, but I think some of them are joining. I just turning it on. Okay. So I hope hysteresis error everyone can understand what is hysteresis error. Now what is backlash error? Backlash error occurs in instrument that has this kind of screw thread, for example. And so this kind of error occurs, for example, because of a gap. And so if you have a gap between two sets of screw thread, when you move one, it doesn't engage until it moves a bit. Okay, so that amount of movement here is known as backlash error. So these kind of problems are related to the instrument. Is that it says backlash, all these are related to the instrument. So the instrument itself can introduce error in the measurement. Now another type of error will be the error in the measurement process itself. The error in measurement process may be due to improper alignment, for example. Okay, assuming that here you are given an object, workpiece, you want to measure the step height over here. Your interest is measurement of D. So if you are using a dial indicator or dial gauge, okay, you'll find that you need to align this vertically. Okay, you need to align this vertically in order to measure this. Okay, now the problem is sometimes, although we try our best to align it vertically, but it may not be perfectly vertical. Now probably you have a very small angle here, maybe about 1 degree or half a degree. Okay, an angle of even 1 degree can introduce an error because the measurement you're taking is along this direction. Okay, it's supposed to be vertical, but then you're measuring along here and then you get a reading. And then you think that that's a correct reading. But when you take this kind of reading, this kind of problem is known as alignment problem. You can also have problem due to parallax, unclean surface, lack of skill, and so on. All these are due to the measurement process itself and the precautions you take during the measurement process. Now, the third most important factor will be environmental factor. The main problem is temperature. Okay, we also have problem due to vibration. Sometimes you have vibration disturbance in the environment, which may cause changes in the readings. Okay, that the vibration has to be minimized.